Hey everyone! So in the last set of 3 videos, we talked about a test called regression. And we saw that regression fit in our bestiary of our statistical test because it had a continuous dependent variable and a continuous independent variable. Well, today we're actually not talking about a test that fits into any of these categories. We're talking about something called correlation. So what is correlation? A correlation looks at the association of two continuous dependent variables. So correlation looks at two continuous dependent variables. So that's really what we're going to focus on. So correlations are really often confused with regressions, and that confusion stems basically from the symbol we use for each test. So we learned with a regression that we use R squared, which is the coefficient of determination, but with a correlation we're using just R, and I talked about this in the regression videos, but I just wanted to reiterate. And this is actually called the correlation coefficient. Okay, so we're going to be focusing on R, the correlation coefficient. And it's really important to distinguish between these two tests because they ask two completely different questions. So with a regression, let's go back to regression. We regress a dependent variable on an independent variable, right? And we're looking for a cause and effect relationship between our independent variable and our dependent variable. And then we fit a line to that. Let's say we can fit this line, which is a positive. We can fit this line. We can have no change in slope. So that's a regression, but that's not what we're going to be talking about today. So with correlation, what we have is something that's not looking for a cause and effect relationship. Whenever we are looking at correlations, we're simply looking at associations between two dependent variables. Okay, so correlations are often exploratory. And what do I mean by that? Exploratory. When we run a correlation, we do that because we have not yet established an underlying biological mechanism for a cause and effect relationship. So correlations are often run before we do a regression. We just see if there are any associations between dependent variables because we don't really have a reason to think one variable causes an effect in the other variable. So this is really exploratory. So for a correlation, we still have our y and x axis, but on one axis we have one dependent variable, and on the other we have the other dependent variable. Now, our null hypothesis for a correlation is basically just a splatter of points with no direction to that association, no positive association or no negative association. So null is a splatter of points. With no positive or negative association. Okay, and we also talked about R, our correlation coefficient, being our test statistics. So another way to state our null is that R equals 0. Now, because of the unique way we look at correlations, we look at two dependent variables, we could also just as correctly have our second dependent variable on the x-axis and our first dependent variable, or on the y-axis, and our first dependent variable on the x-axis. This is just as appropriate. It's going to give us the same answer because we're just looking for an association. Okay, so correlations used to see if there's an association between two continuous dependent variables. And it doesn't matter, before I change this, it doesn't matter which axis you put your two dependent variables on. So let's look at it this way. Let's draw out a few figures for a correlation. Alright, so these two may look like the same figure, and in fact they are. The only difference is we've switched the dependent variables, the axes where the dependent variables were. So here we have our second dependent variable on the y-axis, our first dependent variable on the x-axis, and here we've just switched this around. And you can see that we have these smattering of points going down. So a negative association is what these will be called. Negative association. So these are negative associations, and as you can see, as y1 increases, y2's association, the association is decreasing, and the same thing here, as y2 increases, the association with y1 decreases. But we're not saying there's a cause and effect. We're not saying that increases in y2 are causing decreases in y1. That's not what we're saying. So let's look at a positive association. So again, we can have y2 and y1. And again, we do not fit a line to this because this is not a regression. We're not trying to get a cause and effect relationship. So y1. So both of these are positive associations. So as y1 increases, y2's association increases, so there's a positive association between these two. So again, let's just look at our null. This could be either y1 or y2, it doesn't matter. Same with this, y1 or y2. And the null is that there's no association. So you see no positive or negative direction, there's just no association, period, right? Alright, so what we really want to do whenever we are looking at correlations is we want to establish a sign, positive or negative, and a degree of association. So this would be a positive association. This would be a negative association. But again, we are not trying to place any cause and effect in this at all. We're simply saying, how do these two, are these two dependent variables codependent on each other? All right, so are these two dependent variables codependent? So I mentioned in the regression video that r squared can be any value between 0 and 1 because it's a proportion. The proportion of variation in y as explained by variation in x. Well, with r, with our correlation, r can be between -1 and +1. Alright, so the next video we're going to talk about how to perform correlations in SAS Jump, and it's a bit different than what we've been doing, so stick around. Thanks.